Question 7 is on the Cartesian plane. So this is probably a review for you. René Descartes, a 17th century mathematician, developed a system for graphing ordered pairs on a grid. So the system is called the Cartesian coordinate system. So even if your teacher in the past didn't call it a Cartesian plane, all we're talking about today is how to graph points. So ordered pairs. Something like maybe you'd have an ordered pair like 2, 3. So that is called an ordered pair. There are brackets on the ordered pair, there's a comma in between, and what this is suggesting is that this is our x value and this is our y value. So when we look at our Cartesian plane, what I'd like to always see is an x-axis, and usually we put an arrow on at least the one side, and we would just label it with x, and the y-axis going vertically up the center, and so we could have an arrow up here and just label it with a y. So this is our Cartesian plane. It's divided up into 4 quadrants. So the first quadrant, maybe you had a teacher in the past show you the Roman numerals. This is usually quadrant 1, quadrant 2, and quadrant 3, and quadrant 4. Starting in the top right over here, that's our first quadrant because everything in this quadrant is actually going to be positive. So the ordered pair 2, 3, for example, I would go horizontally 2 and then up 3. So this point where both numbers are positive numbers would be in the first quadrant. Ordered pairs are always written in the same order, and this is something you have to remember. It's always x and then y, so it's just like the alphabet. It never changes. X is always the first number and y is the second number. So example 1, hopefully this is review. We're going to practice plotting some ordered pairs on a Cartesian plane. So first we need to always draw our x and y axis. Okay, and I would label those always with an x and a y. It's just proper to kind of explain that I am actually using the Cartesian coordinate system right now with an x-axis and a y-axis. So every time I see an ordered pair, this is my x and this is my y. This is my x and this is my y, and it never changes. So x is always horizontal, and some teachers, I think they say in the house and up the stairs, in the house and up the stairs. I don't know if that helps, but we're going to go horizontally first and then up or down. So numbers are important. 1, 2, and these are going on the lines. So our positive numbers on the x-axis would go below the x-axis, and then on the left side there's -1, -2 on the lines, -3, -4, -5. This would be 0. We don't often write in the origin 0, but we would have 1, 2, 3, 4, 5 and -1, 2, 3, 4, 5. And then vertically on the left side, we would have 1, 2, 3, 4, 5. And then our -1, -2 going down below. And this is our y-axis. So it's not super important every single time that you write all these numbers on the graph. What I'd like you to always do is leave one line for every number. So don't count 2, 4, 6, 8 or anything other than that when we're graphing ordered pairs. It's really good just to use every line as 1, 2, 3, and they all count for 1. So the numbers vertically should go on the left side of the y-axis. So this first point, 2, 5, means horizontally I would go over 2 and then up 5. And that's point A. Point B, -3, 4. So -3 is this way, and then 4 up here, so that's point B. -2, -6, so sideways first to -2, it's like a number line, and then down to -6, so point C would be down there. D, 5, -1, sideways first, 5 this way, and then down 1, and that's D. E is 6, 0. So those with zeros, sometimes students get worried. So this would actually be E right on the axis. And then F, 0 sideways, always sideways first, 0 sideways, and then down 2. So this is where 0, -2, there's F down there. So hopefully you've seen this kind of thing before. Here is a Cartesian plane already set up for us. And it already has an X and a Y labeled, which is really important. Plot these points and connect the points in order. You're going to have homework today that is kind of a fun page to do. It's going to actually draw a shape. It tells you when to put down your pencil and when to lift it and what segments should be connected. So this one, we're just going to connect all of the points in order, starting this way. So starting with 2, 1. So I would go 2, 1, and then 5, 5, 1, 2, 3, 4, 5, 5. So if we used a ruler as we went, I started here and I connect the points as I go, then you won't get confused with which point is supposed to connect to which point. And the ruler does help, and when we're done, we end up with a nice star. Example 3, decide if each statement is true, sometimes true, or never true, and explain, give examples to support your answer. So a point with one positive and one negative coordinate always lies in the 4th quadrant. So the 4th quadrant, 1, 2, 3, 4, that's this one over here. So a point with one positive and one negative. So just as an example, an ordered pair like 2, negative 1 is that point right there. So that's 2, negative 1. Well, that has one positive and one negative. But then I'm thinking, but what about this point over here? This is negative 2, 1. So that point there is negative 2, 1. That also has one positive coordinate and one negative coordinate. So a point with one positive and one negative always is in the 4th quadrant. I think it can also be in the 2nd quadrant over here. Okay, a point whose x and y coordinates are equal lies in the 1st or 3rd quadrant. So the 1st or the 3rd quadrant would be up in this area, that's quadrant 1 and quadrant 3. So points up here could be 1, 1 or 2, 2. And over here we could have negative 1, negative 1 or negative 2, negative 2. So it sounds like it's kind of true all the time, except what if we had an ordered pair that was 0, 0? A point whose x and y coordinates are equal lie in the 1st or 3rd quadrant. Well, 0, 0 is also, they have the same 1st and 2nd coordinate, but 0, 0 doesn't lie in any quadrant. So that point at the origin is in between all of the quadrants. So I think this is sometimes true as well. And part C, the points on a vertical line have the same x coordinate. So anything that is a vertical line, like I'm imagining a vertical line through 4. So that line, every single x coordinate is 4, 1, 4, 0, 4, 2, 4, negative 1, 4, negative 2. So I think that the points on a vertical line always have the same x coordinate.